Hi everyone, I'm Tracy Smith from Finding Physics. Today I want to talk about right triangle trigonometry. This is just a little introductory lesson to help get you ready for the trigonometry workshop that I'm offering through Finding Physics. And the idea behind the workshop is to review trigonometry skills that are frequently used in your introductory physics class. So let's take a look today just at right triangle trigonometry. And you'll notice as I go through, I'm starting with the basics. I know that you probably have learned all this. I know that you're like, I got this. Just take a listen and make sure all of these details make sense to you. So let's talk a little bit about terminology. When we talk about a right triangle, that means that there is an angle in the triangle that is 90 degrees. And if you take a look in the little sample triangle I have here, there's a little box in the bottom left corner, and that little box indicates that there is a 90-degree angle there. Another way we can state this 90-degree angle, we can talk about the legs of the triangle. So I'm highlighting one leg, I'll highlight the other leg of the triangle, and those two legs of the triangle together make up that right triangle. We say they're perpendicular to each other. So a 90-degree angle also is sometimes referenced as the lines or the legs being perpendicular to each other at that point. Also, when we're talking about a right triangle, not only do we talk about the legs of the triangle, we use the term hypotenuse. And that red highlighted part of the triangle there is referenced to as the hypotenuse. So we have the legs in yellow. Those two legs have a 90-degree angle between them whenever we have a right triangle. And then there's a hypotenuse going from one leg to the other. When we look at a triangle, we can see that there are three different angles in a triangle. Here, there is our right angle, which is 90 degrees. Okay, but there are also two other angles that make up the triangle. There's one here at the bottom and one at the top. Now, those three angles will always add up to 180 degrees. And this is a really helpful piece of information, especially if I know that I have a 90-degree angle and I know one of the other angles, I could solve for the missing angle. Sometimes what I'll do is I will use variables, and we've talked about variables before. I'm going to say theta 1 here. That just stands for one angle, or angle number 1. And down here I'll write theta 2. So that's just talking about the second angles. They're just symbols representing angles that we don't know. And so a statement that I could write is that if I take the one angle, theta 1, and I add to it theta 2 plus 90 degrees, right? Those are the three angles that make up my right triangle. They are always going to be equal to 180 degrees. So again, a very helpful piece of information as you're progressing through different types of right triangle problems. Another thing that we're going to do is we're going to use the sine, cosine, and tangent functions, as well as the Pythagorean theorem, to solve for missing pieces of information on a right triangle. So that opens up another range of relationships that we can use to our benefit if we have a right triangle. All right, so if you take a look over here, I want to talk a little bit as a refresher about the Pythagorean theorem. The Pythagorean theorem is looking at the sides of the right triangle. Okay, so if you take a look at my triangle to the right, I have A being used as a variable for one leg, B is the variable for the second leg, and C is the variable for the hypotenuse. Now, A and B, it doesn't matter which leg they're on, but C always has to be the hypotenuse the way we have the Pythagorean theorem written out. And the Pythagorean theorem is written as A squared plus B squared equals C squared. So as long as you know two sides of the triangle, you can solve for the third. It might require a little algebraic manipulation of the equation, but that's not a big deal, right? So if you know two sides, you can find the third side of the triangle using the Pythagorean theorem if you have a right triangle. The other set of tools we kind of have to work with are sine, cosine, and tangent. And this is the spot where I see a lot of students struggling as we go through and we're working on these different types of problems. So the first thing I'm going to tell you is if you are not really confident and comfortable with using sine, cosine, and tangent, please don't hesitate at the beginning of the year especially to write down SOHCAHTOA at the top of your page and to draw a little triangle to help you decipher what SOHCAHTOA stands for. So let's go through it. The first portion, the first third of SOHCAHTOA, the SOH portion, deals with the sine function. The S stands for sine, the O stands for opposite, and the H stands for hypotenuse. So what that does for us is it says, okay, the sine of theta is equal to the opposite leg divided by the hypotenuse. And I go to my reference triangle. Well, what's the opposite leg? It all depends on where your theta is in your triangle. So right now, theta is in the bottom right-hand side of my triangle. And if I look, the leg adjacent to theta, that's what I call my adjacent leg. The leg that is not touching theta. See how theta has two sides of the triangle touching it? One is the adjacent leg and the other one is the hypotenuse. Okay? This opposite guy, he's not touching theta at all. He's across from that angle. That's why he's called the opposite leg. So again, terminology, we have theta indicates what angle we're talking about in the triangle. And of course, it's not going to be where my right angle is. It's one of the other two angles. And then we have the adjacent leg, the opposite leg, and the hypotenuse. So the sine function is used if we know two pieces of information, either theta, the opposite leg, or the hypotenuse, and we're looking for whatever one is missing. Okay, so when you're looking at these problems and you're like, oh, how do I know if I use sine, cosine, or tangent? It depends. What do you know? And what is it that you're trying to solve? So for sine, if I happen to know the opposite leg and the hypotenuse, oh, I could solve for theta. Or if I know theta and the opposite leg, I could solve for the hypotenuse. Now the other two functions written here, cosine, next. The cosine function, that's the CAH. It's cosine of theta equals the adjacent leg over the hypotenuse. So that's where the CAH comes from. And then the last one, the tangent function, TOA, that means that the tangent of theta is opposite over adjacent. So again, with SOHCAHTOA, as long as you know two pieces of information, you can find a third, and these all include the angle. Remember, on the previous slide, we had Pythagorean Theorem. That was good if we just had side information. Now we're looking at a combo of information in between the angle and the sides. So sine, cosine, tangent are more tools that you have to use when we're dealing with right triangle trigonometry. So how does this play into physics? Well, a lot of times when we are dealing with triangles in physics class, you're going to have two pieces of information given to you in the problem. Maybe it's two sides, maybe it's a side and an angle, and you're going to need to figure out something that's missing. So the typical scenarios, there are two typical scenarios. The first scenario here, it says the hypotenuse and the angle of the hypotenuse are the known pieces of information. Okay, so if I look at my little triangle, we're saying I know a value for the hypotenuse, and I know, say, this angle down here. And if I know those two things, I could solve for the legs of my triangle. How do I do that? Well, I'm going to be using my sine function and my cosine functions to solve for those legs that I don't know the values of. The other scenario that we run into is kind of the opposite. You know the legs of the triangle, and you're trying to solve for the hypotenuse and the angle of the hypotenuse. So if you look at my drawings, in this case, for the second scenario, you would know the blue sections, you would know the legs, and then you would need to use your information to then solve for the hypotenuse and theta. This is a lot of times where we use Pythagorean theorem first to solve for the hypotenuse because you know the legs, and then to get this angle, we use the tangent function. Okay, now going through and doing this, that's what the whole point of my workshop is. Okay, we're going to go through and actually solve a whole bunch of problems where we're doing one of these two scenarios. This ties into something known as vectors in physics. And folks, we use vectors all through the school year whenever we are solving for different things. I have a whole nother set of lessons set aside to talk about vectors, but right now we're just trying to get the basic trig concepts down, so when we get to vectors, you're not like, whoa, what you talking about, Pythagorean theorem? What do you mean sine or cosine? So at this point, what we're trying to do is solidify those trigonometry skills through lots of practice. That's all I'm doing in the workshop. Problem after problem, we'll bring it up, have you work through it, see if you have any problems, and then I can show you how to process a bunch of different problems. So again, right triangle trigonometry, big focus in your introductory physics class. We're going to be using the Pythagorean theorem. We're going to be using sine, cosine, tangent. And through all of this, we'll be able to come up with solutions to really complex problems just with having strong trigonometry skills. So if you need more help, you want more practice with this right triangle trigonometry, you can go to findphysics.com, sign up for the workshops that go along with this, or you could sign up for a tutoring session and we could go through it one-on-one if that's more of what you're interested in. And as always, visit my website to look for other tips, inspiration to help you through your journey of finding physics. All right, everyone, have a great day.